Non-native EMF is at best an environmental toxin. But once you learn this one thing, this specific concept, this law, in fact, then you'll appreciate how you can reduce your EMF exposure in many environments now and into the future. No exaggeration. This concept is crucial for those who want to make serious improvement in decreasing personal exposure to non-native EMF. Hey, you know what? We are electrical beings, and non-native EMF exposures impact us. They just do. They have an effect. You know, an interesting proof of that is that there are medical devices that show a benefit of certain kinds of therapeutic use of EMF. So logically, how could you have one physiological effect but not, a good effect without a bad effect, right? Anyway, there is a concept, a law, in fact, yes, a law that is arguably the most important single concept for managing personal exposure to non-native EMF. A single concept that has huge implications for individual exposure. I'm hopeful that this discussion will be really helpful for everyone who's serious about managing their family's exposure. Now, I have to warn you, if you're not technical, don't be afraid, but you may need to prepare yourself. If you don't consider yourself technically oriented, it's okay. I'm going to explain it, but prepare yourself. I'm going to share 2 words, and just 2, that describe and define this concept, this law. 2 words, sounds kind of technical, but I'll explain it. The 2 words are you ready? Inverse and square. That's it. Okay, the pain is over. The concept is called the inverse square law. I'm going to explain exactly what that means in a minute. Now, I have to tell you how versatile this is. I first put this understanding, not that I had perfect understanding way back then, but I had to learn this concept actually probably before this in college, but I had to use it actually for real life 30 years ago when I began in earnest to study photography. By the way, you know what photography means? It means painting with light. I had to learn it because I had to, otherwise I couldn't progress. My photographs could never achieve the vision that I had. Everybody can relate to taking a picture with on-camera flash. Things closer to the artificial light source would be too bright. Things further away would be too dark in the presence of the non-native EMF that I was using, yes, way back when it was artificial light. And did you know that artificial lighting has something to do with non-native EMFs? What does it have to do? Well, that's a great question. The entire electromagnetic spectrum, all of it, from the Schumann resonance through electric power, radio, TV, radar, cell phone towers of 3G, 4G, 5G, up to infrared light, visible light, ultraviolet light, and beyond are all considered forms of light. Yes, that's right, forms of light. In fact, it's the second definition in many dictionaries. Look up light as a noun. The first definition will be just the visible portion of the spectrum. That's the red, orange, yellow, green, blue, indigo, and violet that we put together in combinations to see everything we can discern with our eyes. Anyway, it all obeys this law, the inverse square law, and it's perfectly legitimate to talk about all forms of electromagnetic radiation as light. You even see it in the scientific literature. Now, there's great power in knowing and exploiting this law, both to get great pictures using artificial light and to minimize personal exposure to non-native EMF. Basically, the inverse square law says that all types of EMF, including non-native EMF, fall off in intensity quickly. How quickly? Very quickly. Much greater intensity close to the source of radiation, much less further away. We'll talk about quantifying that much business in a moment. That's why with artificial lighting, subjects that are close to the, for example, on-camera artificial lighting can get too much light, and those just, 1 foot, 2 feet beyond get too little, and way too little. The ones in the front will be overexposed, and back row, next row, way too little, underexposed. It's also why your neighbor's Wi-Fi will have less intensity of RF exposure to you than your own Wi-Fi router if you still are using one. How much less? Lots. The exposure falls off from the source according to the square of the distance. What's the square? The square is a number times itself. So, for example, 2 squared just means 2 times 2. Okay, that's not scary, right? 2 squared is 2 times 2, which we all know is 4. 3 squared is 3 times 3, which is, fill in the blank for me, 9. 4 squared is 4 times 4, which is 16. Okay, easy, right? In the examples we've just mentioned for the numbers 2, 3, and 4, the squares are 4, 9, and 16. What does inverse mean? Also easy. It just means 1 over, like you're making a fraction. Continue our example with 4, 9, and 16. The inverse of these numbers is 1 over 4, 1 over 9, and 1 over 16. Stated the conventional way, 1/4, 1/9, and 1/16. That's it. Pretty easy. You got the square down, and you got the inverse down. So the intensity at twice the distance from the source is 1/4 of the intensity at the initial distance. I bet a lot of you would have thought half. Twice the distance, half the radiation. No, it goes down to 1/4. The intensity at 3 times the distance from the source is 1/9. I mean, we're getting much smaller numbers. And the intensity at 4 times, 1/16. So the takeaway is that intensity of exposure falls off really fast as we increase distance from a local source. As we go from full exposure to 1/4, 1/9, 1/16, that 2, 3, and 4 times the distance, can you see how these exposures are getting not just a little, but much less as we increase distance? There's tremendous power in knowing this, and there's some good news and a little bad news with this as well. We'll talk about that next time. You should know both because it'll help you in the ongoing battle to find safe places. So first, the good news. Let's assign some units to go with the numbers. What do I mean, units? Well, we know the intensity of exposure reduces from full intensity to 1/4, 1/9, and 1/16 of the from the initial distance from a source 2, 3, and 4 times from the source. But what? 2, 3, and 4 what? Are we talking about inches, miles, hundreds of miles? And the answer is, it doesn't matter. What do you mean it doesn't matter? I mean, You could be twice, 3 times, and 4 times the distance from the source, and it doesn't matter what units. 2, 3, and 4 feet will work? Yes. 2, 3, and 4 yards will work? Yes. 2, 3, and 4 miles will work? Yes. Now that's crazy, isn't it? Yeah, you can pick any units you want. Get one of those units away from the source, measure the intensity of exposure, and then go another unit, whatever you want, fill in the blank. Feet, yards, miles, and of course, for my dear friends in other countries, it's the same for centimeters, meters, and kilometers. This is an international law. So how do we apply this? First, let's look at the law in free space with an omnidirectional radiator. How's that for fancy 50-cent words? Which just means flat ground in the middle of nowhere with no bushes, trees, or any other objects. Oh, and an antenna that radiates the RF equally in all directions. Okay? That'll be the first thing we're going to look at. When I measure the intensity of RF exposure from the omnidirectional source, the antenna that radiates RF without discrimination in all directions, at 2, 3, and 4 yards from the source with an accurate meter, that's key, I expect to measure 1/4, 1/9, and 1/16. Now, let's quit using fractions, shall we? We can turn 1/4, 1/9, and 1/16 into decimal numbers, right? The first one is easy. 1/4, that's 0.25. 1/9 is 0.11, and 1/16 is 0.0625 times the exposure measured at 1 yard. If the measured intensity is, for example, 900 microwatts per square meter at 1 yard, we expect and can measure reduced intensities to 225 and then 99 and finally 56 microwatts per square meter. That's a lot of reduction from moving away 4 yards, right? 900 all the way down to 56. And all we've done is taken a few paces. Radiation falls off quickly. Things get a little more complicated when we introduce objects between the RF source and destination. So if I stick a tree between the router and myself outdoors, well, a lot of that radiation is going to get absorbed. If I stick a brick wall kind of at an angle, there's going to be some reflections going on. So things that can absorb or reflect the radiation, including, by the way, all the objects in a home like walls, floors, ceilings, and furnishings. But in general, in a home environment, you'll see a rapid fall off over distance. That's the point here. A rapid fall off over distance of a nearby radiation source. Now, imagine you don't have Wi-Fi in your home, but you live in a townhouse and your neighbor does have Wi-Fi. Don't you hate that? Just, in fact, on the other side of the shared wall with your unit, you know, because he's not only a neighbor but a friend, and you've been over there and you can see the router, and it makes you want to tear it out of the wall, but you don't. You're a good neighbor. One of the rooms along the shared wall is your home office where you spend a great deal of time, and it's right on the other side of the wall from where you know his router is. Now, the highest intensity seems to be along the wall right where your desk is, okay? You measure, we're going to use the 900 number again, 900 microwatts per square meter at 1 yard from the wall. Way too much for comfort. Of course, you know, because you listen to this podcast, the most effective reduction 100% effective would be removal of the source, but he would probably suspect you. No, but you've talked to your neighbor and he's unwilling. For now, maybe in the future. You remain hopeful. You've decided shielding is out because, well, take your pick. You can't afford it or you're not willing to do it. You've still got increasing distance as a tool because you know about the inverse square law. So your office is large enough to relocate the desk 2 yards further from the wall where you took your initial measurement. Pretty good size office. Guess what? Your reading at that point should be much less, up to 89% less. Carefully walk the area, find the measured lowest intensity because since you're serious about reducing EMF in your home, you have a good quality RF meter, right? So what you would really do is go ahead and move back a distance and then use your meter to find just the perfect spot to put the desk. Much better. Perfect? No, but it's less, and less is good. But Keith, what's this much less and up to 89% reduction? Interactions. Like I said before, what interactions? When radiation interacts with an object, like the wall, ceiling, floor, your desk, etc. It works like this. Some radiation will penetrate, some will bounce off, and some will be absorbed. Crazy, huh? Also, you're not able to measure precisely from the source, which is your neighbor's router, only from the shared wall. So you're making an approximation here. In a home, you'll have lots of interactions. Think of it like this. Let's go back to our example with light, which is a form of EMF. If you take a bare light bulb into a pitch black room, you'll see lots of light near the bulb, less further away. If you pick up the lamp as you walk toward the wall, you'll see more and more light. And not just around the bulb, but you'll see it reflecting from the nearest walls. Not so much for the walls furthest away, but you get the idea. Did you know RF radiation is much like this? It is filling your home with RF when you decide to use a cell phone. It doesn't just make a beeline for the cell phone tower. It bounces all around in your home, filling the space that you're in. Still, lots reflects off of things, like I say, enough to fill the room, but you'll have more near the source and less further away in general. That's why I say much less intensity further away in our example with the townhouse and the home office. And I say up to 89% less. It's because of the interactions. Let's continue with our example. Suppose in your townhouse, your bedroom is on the opposite side of your unit, furthest from the shared wall. In fact, it's another 10 yards. Pretty good sized townhouse. That would be 13 yards total from the initial measured intensity. So 13 squared, that's 13 times 13 is 169. So we take the inverse, which is 1 over 169. And let's get rid of the fraction. We'll just convert that to a decimal, and it's 0.006, or 6/1000ths of the intensity. If you multiply 6/1000ths by 900, we're down to only 5.4 microwatts per square meter, as opposed to the 900 we measured initially. Now, that is quite a reduction. Distance is your friend. when you can't remove the source? Would you be willing to put your desk in your bedroom, inconvenient as that might be, in order to have that much reduction in exposure for free? It's an option to consider, a personal choice you can make. Of course, the inverse square law informs my work in EMF assessment and remediation, but I also use my knowledge of the inverse square law in day-to-day life all the time because, as you know, I am being poisoned by harmful man-made electromagnetic radiation. So I need to be careful about my exposures. If I want to, for example, take my wife out to a new restaurant, I ask where the restaurant's Wi-Fi router is. Now, the silly host thinks I want to be near the router, and then I ask the table as far away as possible. That's if I don't want to take out an RF meter and just measure for the best spot. I don't really like that kind of attention. But hey, just sit furthest from the router. If I visit a church other than our home church, I choose a seat furthest from suspected sources of radiation, including wireless microphones, projection systems, smart screens, sound booths, and unfortunately, other people. Because whenever two or more are gathered, nowadays, you have to assume that they all have active cell phones. So anyway, I'll walk into a church that I don't know very well, and I try to maximize my distance from all of those sources. And if you have to stay, for example, in a hotel, well, you know, it's probably going to have Wi-Fi. And you can simply ask if it's a small hotel or if it's a motel, where is the router? If it's a larger one, you're going to want to know where the routers, plural, are. And choose a room farthest away. I would still measure the levels before accepting the room, but the farthest from a router is a good starting place. By the way, for all the reasons we just talked about, don't stay at the airport, right? You're likely to be nuked by the radar there every 5 seconds. And since you're very close to the source of the radar, it'll be a very intense exposure. I think you get the idea. Even a small distance can be a significant reduction in intensity of exposure to a nearby source of radiation. So this law is why an in-home Wi-Fi router, for example, can yield more intensity of RF exposure than a cell phone tower down the block. It is not because the Wi-Fi router radiates more power than the cell phone tower. Clearly, the cell phone tower could cook you much more quickly from the same distance. It's because the RF from the cell tower falls off quickly over distance, just like every other source of EMF, to the point that the nearby sources of RF can have a greater intensity and therefore account for more of your personal RF exposure. Take some time to let that sink in. Really important, because the closest sources of non-native EMF are in your own home. You can exercise the greatest control of them, not the cell phone tower a quarter of a mile away. An understanding of this law will shed light on what an egregious thing it is from an RF exposure perspective to put a so-called smart meter on your home. because it's typically an RF smart meter, and an RF source very close to you and your loved ones is a bad thing. The inverse square law informs us that close is bad with non-native EMF. So too with natural gas and water so-called smart meters, they are equally egregious. Nothing worse than an RF source close to you. Close is bad helps people to understand why on-body and in-body exposures are the ultimate invasion. The very worst case. A cell phone, wireless, Bluetooth, headphones, and in-body Bluetooth hearing aids, they go in your ear canal and they have an RF transmitter. Can you believe that? Anyway, they can each provide greater intensity of exposure than a cell phone tower close by. Terrible, right? No. Yeah, because you alone control the exposure. You can end it or reduce it by choices that you make, by choosing wired headphones, a landline, or non-radiation emitting hearing aids. You and you alone are in control of on-body and in-body exposures, at least today, as well as all the RF emitting sources within your home. This gives you great power and should be an encouragement to take control of your closest exposures and gain a little distance where possible from close sources you can't eliminate. So that's the great news of the inverse square law, and it's great news indeed. It can take a while to really deeply appreciate all the implications, so I encourage you to spend some time considering what we talked about with the inverse square law, so you can now fully understand or better understand why the Internet of Things and smart appliances are a terrible idea for anyone who doesn't want increased non-native EMF exposure. It's because each results in close exposure from many sources near you and your loved ones. All right, so there is some bad news of the inverse square law, but everything I said about the good is good and will stay good. And I don't want to make this broadcast too long, so we'll talk about the bad news of the inverse square law in a future episode. But in closing, the most important sources of EMF are those closest to you. This makes what happens in our homes most important in reducing personal exposure until society regains its wits with regard to the reckless spread of harmful man-made electromagnetic radiation. Have your home evaluated by somebody competent. Find out what the EMF challenges are in your home so you can reduce exposure for all those under your roof. And if you're building a home, find somebody who can help you make it a fortress against the infringement of non-native EMF. Decide to opt out of what others consider smart meters, smartphones, smart homes, smart watches. Embrace a little inconvenience now and then, and take your amusement and stimulation from the natural world. Our homes are the last bastion of defense. Take control of yours. Take the EMF Remedy. Thanks for your time and attention. If you find value in reversing electromagnetic poisoning, please consider becoming a sponsor. The link is in the description, and please tell a friend. I want to help them too. I'd love it if you left a review for the podcast, and super looking forward to next time. God willing, we'll see you then.